Hey everyone, welcome back to the channel. This is Fresh Forensics and I am Douglas Habian. Today we're going to be diving into the fascinating world of Android forensics. We're going to be leveraging the power of ADB, or Android Debug Bridge, in order to do live analysis on a mobile device that is running the Android operating system. The main purpose of this video is to show you how incredibly powerful ADB commands actually are and how much information you can get from a mobile device running Android simply by leveraging ADB commands. Alright, so with that being said, go get your Android phone, pull up a chair in front of your Linux workstation, and let's go ahead and get started with the video.
Fresh forensics on my chest like a badge. Self-taught, stayed hungry, made the struggle my path. They ain't see the vision, marked the way I move, but I kept on running even when I couldn't improve. Idea in my head, couldn't leave it behind. Built it from scratch, one USB at a time. They ain't hire me fine, I made my own lane. Turned passion to a brand, now they all know the name. Yeah, Linux ain't a system, it's a part of my core.
Now, as you're about to see today, working with tools like ADB is a great way to collect data quickly and start analyzing Android devices. But mastering forensics and understanding the deeper technical concepts behind these tools takes a solid foundation in problem solving, logic, and critical thinking. And that's where Brilliant comes in. Brilliant offers interactive courses in math, computer science, programming, and data science, all designed to help you think like a problem solver. Their hands-on lessons walk you through real-world challenges, step by step, so you're actively learning by doing. By strengthening those fundamental skills, you'll be better equipped to tackle complex fields like digital forensics or even cybersecurity. To start learning for free, head over to brilliant.org/freshforensics. or scan the QR code on the screen. Brilliant is also giving our viewers 20% off an annual premium subscription, which gives you unlimited access to everything on their platform. I would like to thank Brilliant for sponsoring this video. If you head over to github.com/DouglasFreshHabian, this is kind of the starting point for all of my various GitHub repositories. On this page, you can learn a little bit more about me and about Fresh Forensics. If you come up here to the top and click on repositories, it will take you to this page where we get a listing of all of my various repositories. And the first one up here at the very top is a brand new repository that I just created a few days ago. This is called Android Forensics. And this is very important because much of what I am doing in this video, you will be able to find over on this GitHub repository. The commands that I am running, you are able to copy and paste straight from this GitHub repository. I am also going to be displaying some very powerful bash scripts. And those bash scripts are available inside of this GitHub repository as well. So the repository is aptly named Android Forensics. And this is meant to be a simple and practical guide that will give you the ability to extract digital artifacts from Android devices, specifically using ADB, also known as the Android Debug Bridge. This can be used by an investigator, a researcher, a security enthusiast, or just a person that's interested in understanding their phone, which is running Android. This repository will walk you through the process that I am showing you in this video of using ADB commands to gather system and app level data, and specifically on a non-rooted device running Android. And that is very important that we make that distinction. Everything that we are doing on a non-rooted device. Now, if you are looking to get access to more information or all of the information on the phone, then at that point, you're going to want to root the device. We'll look at that in a future video, but for this video, we are solely focused on the power of using ADB commands to get information from the phone on a non-rooted device. So we are, of course, using our Linux system. I'm using Ubuntu Linux. First thing that you're going to want to do is make sure that you have ADB installed. I can run apt search on ADB. We'll get back quite a bit of information if we scroll up here to the top. We have two different choices. So you have ADB, which is the Android Debug Bridge, and then you also have the Android SDK platform tools common, which is a broader set of tools that can also be used for interacting with the Android platform. We're not interested in that. We are solely interested in the Android Debug Bridge. So if you do not have that installed, it's very simple. Just run the command sudo apt install ADB. And once you have ADB installed, ADB has a wonderful set of options available with it, and you can pull those options up by running ADB with --help. And if you are not familiar with ADB, or this is your first time using it, ADB is incredibly powerful. I mean, we could do video upon video on all the different ways that we can run ADB commands and get information from the device or just interact with the device in general. The first phone that we're going to get up and running is the phone I did a previous video on. This is a Samsung, has a cracked screen. The screen is no longer responsive. So I'm going to plug in the phone. Now Linux has this wonderful command. It is the lsusb command, and it is used to list USB devices. And since this is connected via USB, we should be able to list out the device and get some more information on it. So if I run lsusb, we're going to get everything that is connected. And we can see right here that here is the Samsung phone. So I don't want to show you everything. So I'm going to rerun lsusb, and I'm going to pipe that into grep. I'm going to grep for Samsung, so we only get that line. All right, so this is letting us know the phone is connected. And in addition to letting us know that it's connected, it's even able to tell us that it is in the proper mode, or in other words, USB debugging is enabled. If you don't know how phones work, phones have different modes. One phone can have several different modes that it operates in, and those modes will give you different identifiers. So USB debugging is its own mode, and what's wonderful about this command is we are able to even gather information like that from the phone. So we know that this phone already has USB debugging enabled, and it also has network tethering enabled, which means that we can share the internet connection from the phone to the machine if we have it connected via a USB cable. So I'm going to go ahead and start up the Scrcpy utility. And if you don't have that installed and you want to install it, it's very simple. Just run sudo apt install Scrcpy. That's Scrcpy. I'm going to start up Scrcpy, and I'm going to do -- always -on -top, and that basically makes sure that the phone that is going to be displayed on the screen here in a moment is always on top of everything else on the desktop. And there it is. There is my Samsung phone. And even in spite of a cracked and unresponsive screen, by using this wonderful, powerful command line utility, we're able to display and control the Android phone. So in order for you to benefit from or leverage the ADB commands that we are about to use, the very first thing that you're going to have to do, other than installing ADB, is you're going to have to enable USB debugging on your phone. So I'm going to show you how you can do that real quick. On any phone that is running Android, it is almost an identical process. First thing you're going to do is go to the settings in your phone, whether that is by clicking on the settings app or going to the top of the phone. There's various ways to get to the settings, obviously. So I'm going to click on Settings, and I'm going to scroll down to About Phone. Now, I already have developer options enabled, obviously, but we're going to pretend that I don't for a second. You're going to go to About Phone. I'm going to go into Software Information, and I'm looking for build number. That is ultimately what you are looking for, is build number. Wherever that is located on your phone, you want to find build number, and then you want to click on it 7 times. Once you click on it 7 times, it will ask you to put in the password to log into your phone, and then it will enable developer mode. Once developer mode has been enabled, you can back to the main settings page, and at the bottom you should have a new tab that is now available to you, and that is the tab that you see here at the bottom of my screen, and that is Developer Options. We're going to click on Developer Options. We are looking for USB Debugging. Here it is right here. Obviously, I already have it enabled to be doing what I am doing, showing you the phone on the screen. So go ahead and enable USB Debugging. We can go back to the command line. I no longer need to have Scrcpy up and running, so I'm going to Control-C out of that. Now we are still connected to the phone via USB, and USB Debugging is enabled. We have ADB installed, so we now should be able to send ADB commands to the phone. We're going to go ahead and run ADB start-server. That will start up ADB. At this point, you probably are going to get a prompt on the screen of your phone asking you to allow USB debugging. Go ahead and click on Allow. Once you have done that, you should now be able to run ADB devices, and you should get back something in your list of devices attached. So you can see that we are attached to this device, and over on the left we have the serial number for the device. So we're going to head back over to the GitHub page. And we have already done the first step of this. So we're able to verify the ADB connection by running ADB devices. So if we go back to the GitHub page, perhaps the first thing that you're going to want to do is gather some basic system info about the device as well as the system state. We can do that using the ADB shell git properties command, or git prop. So if I just run ADB shell git prop, it will give me back pretty much everything. We can save this to a file. There's a lot of information here. Very, very specific information. Now, if we are looking for just that one piece of information, that very specific piece of information, then we can refine this command, and we can run ADB shell git prop with ro dot serial number and get the serial number of the device, or we can do ro dot product dot model, and this will give us back the product model number of the phone. Because I'm using the wonderful fish shell, I also have auto completion. I can run ADB shell git prop ro dot and then tab. It will show me all of these specific properties that I may want to search for, and there are clearly a lot of them. There are hundreds of them. Now, as these commands get a little longer and a little bit harder to memorize and to run, remember that you can simply go over to my GitHub page and you can copy and paste these commands. I've made it very simple for you guys to follow along. All right, so if we move on to number 3. Number 3 has to do with how to retrieve information on installed packages. So these are some very well-known commands. I'm not going to spend a lot of time on them. I want to get on to what I feel are the more important commands, forensically speaking, but we can just copy and paste this. This will list all the installed apps as well as their installation paths, the path to the location of the app on the phone. and we'll get back a lot of information because there's a lot of apps installed on this phone, and this is the actual path to each one of those apps. Now we can also just run that with no options. I'll get rid of the -F, and what this will do is this will actually print to the screen every single application that is installed on the phone. And if you've never done this before, this is very interesting when you find out just how many applications you actually have installed on your phone. So for this particular phone, if I rerun that command and I pipe that into word count with a -L, we get back that there are 361 applications installed on this phone. Many of those there are not apps for. There are not app icons for, so you don't know that they're installed on the phone because there is not actually an app icon for you to press and interact with the application, but nonetheless it is installed. And you can see that most of them start with com dot and then something that follows that. That is the naming convention of these apps. Com dot Android, com dot Samsung, etc. and so forth. So one of the things that I always think is interesting to do is let's see how many applications on the phone are actually Google related applications. So I can rerun that command and we will pipe that into grep. I'm going to do -I for case insensitivity, and we're going to look for anything that has the name Google in it. And we'll get that list printed to the screen. And if we rerun that command and pipe that into word count with a -L, that will give us a count. So it looks like there are approximately 55 apps on this phone that are Google related apps. Another thing that you can do is you can run ADB shell PM list packages with a -3. This will list all of the third-party applications installed on the phone. Third-party basically means applications that do not come default with the phone or the manufacturer of the phone. These are applications that typically are installed via the Play Store. So when you go out to the Play Store and you install something, that application is going to show up in this list. So that includes, for example, a Venmo app that is installed on this phone. Now, if you're looking for a specific app, you want to get information on that specific app, this is an easy way to get the name of that app. So let's hone in on one of these apps. We're going to use Tutanota for our example. It's up here at the top. If you don't know what Tutanota is, this is end-to-end encrypted email. Very, very good stuff to be using. So this is the name of the package. I'm going to copy the name of the package, and we can actually rerun this command. We'll do a -F, which will print out the path to the app, and we're going to pipe this into grep, and we are going to grep just for the Tutanota application. And what we get back is the path to the Tutanota app on your phone. Now, once you have that path, if you would like, you could then extract the app from the phone. It's a little bit outside of the scope of what we're doing in this video, but there are certain situations where you might want to actually extract the app and take a closer look at the app. And in order to do that, you first need to know the path to the app, and that path is always randomized. But once we get the path, we can actually just copy that. We're going to copy this information all the way up to the equal sign. I can run ADB poll, paste in that path location, and it will extract the app from the phone. I can do an ls-lh. It currently has the name of base.apk, and there it is. And then we can move forward and extract or decompile the app and look at the internals of the app. That's outside of the scope of this video, but that is nonetheless how you would do that. So moving forward. Okay, so the next thing that we're going to take a look at is going to be how you can use ADB Logcat to collect system logs from your device. Now once again, over on my GitHub page, I've made this very easy for you. You can copy and paste the command. Now, there are several different ways that we can run this. You're going to get back a lot of information. If I just do this with -d, this will dump all of the logs. We're going to redirect the output to a file. So this will dump all of the logs, save everything to the file, and then exit, as opposed to continuously streaming. Now that has completed. This is going to be a very large file. If I do an ls-lh on that file, it's 42 megabytes in size. If I do a word count on that, we're looking at 332,000 lines long. So this is a lot of information, and when you are looking for forensic artifacts, well, it's better to have access to more information than less. But when you want to actually get down to looking for very specific things, this is obviously where something like grep is going to be extremely useful. You can grep through the logs and look for very specific things. But there are several other ways that we can run Logcat that are worth taking a look at. One of the ways that I love to run Logcat in real time is by adding colorization to the logs. So if I just run ADB Logcat with no other options, you will see that it will start to stream logs in real time from my phone. And I can actually begin to interact with the phone, and you see the logs start to slow down. And if I start to interact with the phone, start to move it around a little bit, you see the logs pick up. And that is because pretty much everything that you do on the phone is being logged in some respect, down to even tilting the phone, because the phone does have an accelerometer inside of it. So even information about the movement of the phone, even touching the screen, even if you weren't actually doing anything, simply touching the screen is enough to provide you with information in logs. So that right there tells you that you can get an incredibly large amount of information from the logs. You just have to know how to read them and sift through them. But this is just not going to work. So one of the things that we can do to make this a little bit more visually pleasing to the eye and help us to better differentiate one event from the next is going to be to run ADB Logcat with -v, and we're going to specify color. So now we're getting some colorization. At this point, it's still scrolling by too fast to actually see anything, but once we get near the end, it starts to slow down. You're actually going to begin to see some of the stuff that's going on. And now we can actually make out some stuff coming back from the accelerometer. It's showing up in green. And this does at least make it a little bit easier to understand. Now, if we want to begin to narrow in on more specific things, we can rerun the logcat command. We're still going to do color, but we can specify buffers with a -b. So let's say that I only want to look at a specific log buffer, such as the radio log buffer. All right, so we'll still get logs in color, but this is focusing solely on those logs having to do with the radios on the phone. Specifying the radio buffer is going to provide us with logs that pertain to, amongst other things, network operations like telephony and Wi-Fi. Now, if we were interested in system level logs, we could specify system instead, and we're going to get back colorized logs having to do with the system. So number 5 has to do with extracting battery and power data. So we can actually use ADB shell to gather device power metrics. Now this is the first command where we are going to use Dumpsys. Dumpsys is an incredibly powerful addition to the ADB commands that we have at our disposal. Now this is coming straight from the Android developers page on Dumpsys. Dumpsys is a tool that runs on Android devices and provides information about system services. You can call Dumpsys from the command line using ADB, and you can use that to get diagnostic output for all system services running on a connected device. And it even says right here that the output is very verbose, meaning you get a lot of information back. So it gives you the general syntax. Typically, the way I like to start off with Dumpsys. Dumpsys is just incredibly powerful. It's actually what we're going to use for a lot of the commands that we run in the remainder of this video. But usually the first thing I like to do is just run ADB shell Dumpsys with a -L. That will actually just list out all of the services that you have on the phone. And once again, there are a lot of services. If we were to rerun that and pipe that into word count with a -L, we're looking at 264 different services. This is basically the bread and butter of this Android device. So if I print those to the screen, if I print that list to the screen once again, we can see that amongst other things, we have services relating to the telephony portion of the phone. We have services related to the Wi-Fi running on the phone. We have services related to the management of the VPN. Pretty much everything has a service behind it, and you can get a lot of very good information from the device if you have an understanding of these services. So for example, let's say that I wanted to get information back on all of the Wi-Fi access points that this phone may have connected to. Well, an easy way of doing that would be to run ADB shell Dumpsys, and then at this point we can specify one of those services. So we will specify the Wi-Fi service. Some of this I'm gonna unfortunately not be able to show you because I don't want to show you the Wi-Fi access points that I'm actually connecting to, but you're going to get back a lot of information from this command, and you could actually rerun that and you could grep for SSIDs, and what you will get back are various SSIDs, or the names of the access points that the phone has connected to. So I'm going to blur this out, but I am getting back the name as well as the MAC address of the most recent access point that I've connected to. So what a great way to figure out which Wi-Fi access points the phone has been connecting to. All right, so I have shown you several very powerful commands, all leveraging the power of ADB as well as Dumpsys, that will allow you to extract information from the phone that you can then use to get a better understanding of what may have been taking place with that device or the person using it. We're only scratching the surface because there's so much more that we can do, but very quickly you realize that there are a lot of commands and there is a lot of information that you get back. So what I have done to try to speed up this process, make this much simpler and much quicker and more effective, is by creating some bash scripts. So if we scroll further down the page over on the GitHub repo, we come to the section that is called Included Scripts. So this repo includes 2 different bash utilities that will automate and standardize your data extraction workflow. One of those scripts is called Extract.sh. The other one is called Dumpsys.sh. And if we scroll back up to the top, you will see both of those inside of this directory. So at this point, if you haven't done so already, it would probably be a good time to do a git clone. So we're going to click on the green box copy the URL to the clipboard, go back to the command line. If you do not have Git installed, just run sudo apt install Git. We're going to do a Git clone of the repository. Once the Git clone has finished, you can cd into the newly created directory that is called Android Forensics. Inside of that directory, you have both of the bash scripts, and we can make both of those scripts executable at the same time by running chmod +x. We're going to specify an asterisk followed by .sh, and this will run that command on any and all bash scripts inside of this directory, and now they are ready to run. So back on the GitHub page, we have a breakdown of each one of those scripts. You can click on the section right here underneath each script. You can expand out each section, and it'll give you quite a bit of information on each one of those scripts. So the first script we're going to take a look at is actually going to be the Dumpsys.sh script. All right, so what does this script do? It is essentially an automated Android diagnostics collector. It will connect to the device over ADB, and it will run a series of Dumpsys commands, such as the Dumpsys commands that I showed you in the video, as well as several additional Dumpsys commands. Each one targets a key Android system service, and then it saves the output into an associated text file, and it essentially organizes all the text files in a directory. So here is a brief listing of some of the Dumpsys commands that are ran. This is not all of them, this is some of them, and you can obviously very easily add more to the list if you so choose to. All right, so let's go ahead and run the script. This is the Dumpsys.sh script. Do forward, I'm going to do a // followed by Dumpsys.sh. The device is connected. Everything is going to be printed to the screen. The output is colorized, and at the same time, everything that you see printed to the screen is also being saved to different files. It's pretty quick, so it has already finished running, and what you get at the bottom is a listing, a summary of all of the commands that were executed. So we have 22 different commands that were executed. None of the commands failed, so we have a 0 for failed commands, and then all of the output was saved to this directory right here. So we can scroll back up through the output if we would like. All right, so as I said, there's a lot of information here. There's really too much information, right? So if I do an ls, I now have this newly created directory. It's a dumpsys report. I can cd inside of the report, and if I do an ls, now we have all of these files, and we can look for specific things. So for example, if I want to get if I want to see which accounts are registered on things on this device, I can simply cat out account.txt. If I want to look at networking information, I can take a look at the netstats.txt file. If I want to see which Wi-Fi networks this phone was connecting to, that information is going to be available inside of wifi.txt. GPS and location information is going to potentially be available inside of location.txt. All of the packages are going to be available in package.txt, as well as additional information pertaining to the packages, like the permissions of the packages. If I expand out the Extract.sh script, which probably should go second to the Dumpsys script, this script is considered to be a little bit more advanced than the previous script, it not only gathers system diagnostics, but it also extracts user level data. So we're talking about contacts, call logs, SMS, accounts, etc. and so forth. All of those commands that I ran earlier in the video, it's going to run all of those commands as well as additional commands. It's going to do it all for you and save the information for you. And it's all going to be done for you very quickly. And all you have to do is just run one script. Just as the previous script did, it's going to create a directory and save everything inside of that directory. This is going to start with ADB report, and it will have an associated timestamp after that. So you can run this multiple times on the same phone and get different timestamped folders every time that you run it. I would say that this is probably the quote-unquote juiciest of all of the information and probably the most valuable. And I also decided to add a little bit more power to the script, and it will automate the process of obtaining a bug report. Now, obtaining a bug report is pretty simple, but I thought, why not include it in the script for you? Once again, we're going to head over to the documentation for Android. I will leave the link in the description. So there is a page under the developer's documentation for Android that explains what a bug report is and the various ways that you can capture a bug report from an Android device. And a bug report contains device logs, stack traces, as well as other diagnostic information that can help you find and fix bugs in your app, but also it just contains a lot of information that can be very valuable. All right, so let's go ahead and run the Extract.sh script by specifying a / followed by the name of the script. And we get all of this information printed to the screen. It is colorized. We're basically seeing the SMS logs dumped to the screen. The majority of the script runs very quickly. It's basically done, and now it is generating the bug report in the background, kind of. So we get this summary at the bottom. Here are all of the files that were created, and we get the sizes of those files on the right. And the results have been saved to this directory. And the total runtime was 11 seconds, not including the generation of the bug report, which is almost complete. And there we go. So at the very bottom, the bug report has completed. It has been saved to this path, and if I hit enter, we exit from the script. So now we have a directory starting with ADB_report. CD inside of that directory. Do an ls, and here are all of our files. And in the upper left, the first file that we have is the bug report. We're not gonna delve into that, but just know that in and of itself, there is an enormous amount of information contained inside of that bug report. But just like the other script, we have everything saved to files with names that correlate to the information that we're looking for. So if we are looking at the call logs, we can cat out the call logs.txt file. If we are looking at the contacts, there are the contacts. We have all of the email addresses in use on the phone, number of reboots. We have network info, including the IP addresses. Quite a bit of information. This is the juicy information right here. This is the valuable information that I think most people would probably be looking for. And we also have a quick snapshot using Logcat. So if I do a word count on that to to get the number of lines. This is 1,000 lines long. So I believe this is taking the first 1,000 lines from Logcat. Yeah, so this is starting at the beginning. Just the first 1,000, nothing crazy. Because we got enough information going on everywhere else. So yeah, so that's the second of the two scripts. And obviously, we can add more functionality to these scripts. You can head over to the GitHub and you can put in a Git request if you would like to see something else added to the script. I would love to know if anybody out there watching the video has been able to use any of these scripts, and if they were able to use them, what do you think? Were you able to have some level of success in using the scripts and getting information from the device? Let me know your thoughts. I'm very curious to know what you guys think, and if you would like to see more videos on mobile, more videos on Android, let me know. Once again, links are in the description, and go check out the GitHub page. As always, keep learning and stay fresh. We'll see you in the next video.
Yeah. Fresh forensics, baby. Straight from the lab. Let's go.